Welcome back to Jackson Square. Today we're going to be looking at TEK 6.7a, which says, I can generate equivalent numerical expressions using order of operation, including whole number exponents and prime factorization. So today we're going to be looking at prime factorization. But before we get started, we need to know what is a prime number and what's a composite number. A prime number has factors of only 1 and itself. For example, 3. The only factors of 3 are 1 and 3. Okay, so prime numbers only have 2 factors, 1 in itself. That means that it doesn't matter where I go in the world, the only numbers I can multiply to get 3 is 1 times 3. The only numbers I can multiply in the world to get 2 is 1 times 2. I can only multiply 1 times 5 to get 5. There are no other numbers I can multiply to get 5 or 3 or 2. There are no other numbers. So prime numbers only have 2 factors, 1 in itself. Composite numbers. A composite number is a whole number that has factors other than 1 in itself. Okay, so more than 2 factors. So 3 factors will make it composite. So an example of something with 3 factors is 9. I can multiply 1 times 9, and I can also multiply 3 times 3, which gives me 3 factors. You only count the 3 once. So 1, 3, and 9 gives me 3 factors. So 9 is composite. It is not a prime number. Example, 8. The factors of 8 include 1 times 8, 2 times 4. Those are the factors of 8. So there are 4 factors for 8, so thus 8 is composite. Circle all of the prime numbers and box all of the composite numbers. Well, we're just going to circle the prime. 18, I know 1 and 18, 2 and 9, so that's not composite. 5, well, I know that 5 is definitely prime. The only numbers I can multiply to get 5 is 1 and 5. 7 is definitely prime. Did I say composite, y'all? I mean prime. 7 is prime. 5 is prime. 20, 1 times 20, 4 times 5. 22, 1 and 22. 9, we already said 9. 16, nope. 45, no. 38, no. So I know 38 is 1, 38, and 2 times something. So I know it's 3 factors. Same with 26, same with 30, 15, 2. 2 is composite. I mean prime. Why do I keep saying composite? Prime. 10, no. 21, no. 19. I think 19 is prime. I'm not sure. I can only think of 1 and 19. 6, no. 3, yes. 14, no. 11, yes. So the way that I know is if it ends in a 2, 4, 6, or 8, I know that it can be evenly divided by 2. So I know 1, the number, and 2 are factors. So I know that it's not going to be prime, that it has at least 3 factors. If it ends in a 5 or a 0, I know it's divisible by 5 and itself in 1. So I know it's not going to be prime. Also, I can look at just what I know. If I know another pair of factors besides 1 in the number, I know that the number is not prime. Like 21, I know 3 times 7 is 21. Plus I have 1 and 21, so I know it has 4 factors, so I know that it's not prime. And now, just to check, I'm going to look at my sieve of Eratosthenes to check and make sure that 19 is prime. That's the only one I don't quite know. So here's our sieve of Eratosthenes, and all the numbers that are circled are the numbers that are our prime numbers. All the other colors tell you that they are factors of different things. Like all the greens are numbers that can be evenly divided by 2. All the reds are things that can be evenly divided by 3. All the blues are numbers divided by 5, and so on. So 2 is circled, 3 is circled, 5 is circled, 7 is circled, 11 is circled, 19 is circled. So 19 is definitely a prime number based on the sieve of Eratosthenes. So I think we got them all. So this is prime factorization. And you need to know a prime number can only have two factors, one in itself. A composite number will all have more than two factors, that's 3 and up, to make it prime composite. I'm not doing well at this video today, okay? Sorry, people. Prime factorization. To determine the prime factorization of a number, you must break down a number into its factors. Factors, hopefully you remember, are numbers that we multiply to get the product. So we're going to break it down into factors. Continue until all the factors are prime numbers. Remember, prime numbers are numbers that only have two factors. Prime factorization is written in exponential form. So it can be written in expanded form or exponential form. We have used prime factorization before to help us find the greatest common factor, the GCF, when simplifying fractions. So for some of you, this will not be new, and for some of you, this is still a challenge. So we get in that great practice here. So we're going to take a number that's normally composite, break it down with two factors, and keep breaking it down until we only have prime numbers. And then I'm going to teach you how to write it in exponential form.